The Bristol Beaufighter entered service in 1940 as a night fighter and strike aircraft with a reputation for heavy firepower and solid construction. It carried 4 20mm cannons and 6 machine guns in the nose. It could mount torpedoes, rockets, and bombs. It was fast enough to intercept bombers and sturdy enough to absorb combat damage. Crews respected it. Commanders valued it. But from the first operational flights, pilots reported a handling problem that would never be fully resolved. The aircraft had a tendency to swing violently on takeoff and landing. Not occasionally. Consistently. The swing was sudden, severe, and difficult to correct. Pilots who failed to anticipate it lost control. Aircraft ground looped. Undercarriages collapsed. Some pilots were killed. The problem was identified immediately. Engineers understood the cause, but the Beaufighter remained in production and operational service for the entire war without a complete fix. This was not a minor inconvenience. This was a design flaw that killed pilots and damaged aircraft, and it was tolerated because the alternatives were worse. The Beaufighter was developed rapidly in response to the urgent need for a night fighter capable of carrying airborne radar. Bristol Aircraft adapted the design from the existing Beaufort torpedo bomber, using the same wings and tail, but installing more powerful engines. 2 Bristol Hercules radial engines producing over 400 horsepower each. The fuselage was redesigned to accommodate the heavy nose armament and a second crew member to operate the radar. The result was an aircraft that could find enemy bombers in the dark and destroy them with concentrated firepower. The RAF needed this capability immediately. German night bombing raids were causing significant damage, and existing night fighters were inadequate. The Beaufighter was fast for its size, reaching speeds over 320 miles per hour. It had good range and endurance, allowing it to patrol for extended periods. The armament was formidable. Nothing in the RAF inventory carried as much forward-firing firepower. The aircraft was also robust, with a strong airframe that could absorb battle damage and continue flying. These characteristics made it valuable for multiple roles beyond night fighting, including anti-shipping strikes, ground attack, and long-range escort. The design was practical, and it could be produced quickly using existing manufacturing infrastructure. Commanders accepted the Beaufighter, despite the known handling issue, because there was no alternative that could be fielded quickly. The Mosquito, which would eventually replace many Beaufighters, was not yet in production. Existing night fighters like the Blenheim and Defiant were inadequate. The Beaufighter, with all its flaws, was the best option available. The decision was made to proceed with production and deployment while efforts continued to mitigate the swing problem. The urgency of the strategic situation outweighed the operational risk. Pilots would have to manage the flaw. The aircraft would go to war as it was. Testing had revealed the swing tendency early, but the severity of the problem only became fully apparent under operational conditions. Test pilots flew the aircraft from established airfields with long, paved runways. They were experienced and briefed on the handling characteristics. They flew in daylight with good visibility. They operated aircraft that were well maintained and at standard weights. Under these conditions, the swing was manageable. Test pilots could anticipate it and correct with rudder input. The problem was noted. Recommendations were made, but it was not considered severe enough to halt production. Operational conditions were different. Beaufighters operated from grass airfields, many of them improvised and poorly maintained. Runways were short. Surfaces were uneven. Night operations were common, with limited visibility and no margin for error. Aircraft were often overloaded with fuel, ammunition, and external stores. Pilots varied in experience, from veterans to newly trained crews who had limited time on type. And missions were conducted under pressure, with fatigue, weather, and combat stress all reducing the pilot's capacity to manage a difficult aircraft. The gap between test conditions and operational reality was significant. The swing was most dangerous during takeoff and landing, when the aircraft was at low speed and the pilot had limited control authority. A Beaufighter accelerating down the runway would suddenly veer to one side. The pilot had to apply immediate and aggressive rudder to counter the swing. If the correction was too late or too weak, the aircraft would continue to swing, the wingtip would strike the ground, and the aircraft would ground loop. If the correction was too strong, the aircraft would swing in the opposite direction, potentially with the same result. The problem required constant attention and precise control inputs at the most critical phase of flight. The first squadron to receive the Beaufighter operationally was No. 25 Squadron, tasked with night interception duties in late 1940. Pilots transitioned from Blenheims and began flying patrols over England. The aircraft's performance was immediately appreciated. The radar worked. The firepower was devastating. Interceptions were successful. But within the first weeks of operation, the squadron experienced multiple ground accidents. Aircraft swung on takeoff. Several ground looped. One aircraft was damaged beyond repair. No enemy action was involved. The accidents were all attributed to the handling characteristics. Pilots reported that the swing occurred without warning. The aircraft would be tracking straight down the runway, and then suddenly it would veer. The rudder was effective, but the pilot had to anticipate the swing and apply correction before it became severe. If the pilot waited until the swing was noticeable, it was often too late. The problem was worse in crosswinds, worse on rough surfaces, and worse with heavy loads. It was also worse at night, when visual references were limited and the pilot's workload was already high. Some pilots adapted quickly, others struggled. The variation in pilot skill became a factor in accident rates. Squadron commanders recognized the problem and implemented additional training. Pilots were briefed extensively on the swing tendency. They practiced takeoffs and landings with instructors, emphasizing the need for early rudder input. Some squadrons developed techniques, such as holding the control column back during the takeoff run to keep weight on the tail and reduce the tendency to swing. These methods helped, but they did not eliminate the problem. The aircraft remained difficult to handle on the ground, and the accident rate remained higher than acceptable. The cause of the swing was well understood. The Beaufighter had a relatively short fuselage and widely spaced engines. The propellers, which rotated in opposite directions to cancel torque effects, still produced asymmetric thrust during the takeoff roll. As the tail lifted and the aircraft accelerated, the thrust line changed relative to the center of gravity. This created a yawing moment. The rudder, which was the pilot's primary tool for countering this yaw, was less effective at low speeds. The tail wheel, which provided some directional stability while on the ground, lifted off early in the takeoff run, reducing its stabilizing effect. The combination of these factors meant that the aircraft was inherently unstable during the transition from ground roll to flight. The problem was compounded by the undercarriage design. The main wheels were positioned relatively far forward, which reduced the lever arm for correcting a swing. Once the aircraft began to yaw, the geometry made it difficult to stop the rotation. The pilot's correction had to be immediate and strong. Any delay allowed the swing to develop momentum, and once that momentum was established, recovery was difficult. In some cases, the swing was so rapid that the wingtip struck the ground before the pilot could react. The result was a ground loop, collapsed undercarriage, and damaged aircraft. Testing had exposed this behavior, but the test environment had minimized its severity. Test pilots were highly skilled and specifically briefed. They flew from long, smooth runways with ideal conditions. They did not carry combat loads. They did not operate at night. They did not experience the cumulative fatigue of operational flying. Under test conditions, the swing was manageable. Under operational conditions, it was a consistent hazard. The difference was not in the aircraft. It was in the context. Modifications were attempted. Bristol engineers experimented with larger rudders, revised tail configurations, and changes to the undercarriage geometry. Some modifications provided marginal improvement. The introduction of a larger tail fin on later models helped slightly. But no modification eliminated the problem. The fundamental issue was the relationship between the fuselage length, engine placement, and center of gravity. Correcting this would have required a major redesign, essentially a new aircraft. That was not feasible during wartime production. The Beaufighter was needed. Factories were tooled. Pilots were trained. The decision was made to continue production and accept the flaw. The operational consequences were significant. Accident rates for the Beaufighter were higher than for comparable aircraft. Pilots were lost not to enemy action, but to ground handling accidents. Aircraft were damaged and removed from service. Squadrons had to allocate additional training time to address the problem, which reduced operational availability. And pilots, knowing the aircraft was difficult, approached every takeoff and landing with heightened tension. This was not a confidence-building characteristic. Pilots developed individual techniques for managing the swing. Some held the tail down as long as possible during the takeoff roll. Others applied preemptive rudder before the swing began. Some reduced power slightly on one engine to reduce the asymmetric thrust. These techniques were shared informally within squadrons, but they were not standardized. Each pilot had to find what worked for them. The aircraft demanded constant attention and precise control during the most critical phases of flight. This was mentally exhausting and increased the risk of error. Commanders recognized that pilot skill was a variable they could not fully control. Some pilots handled the Beaufighter well. Others did not. The decision was made to assign the most experienced pilots to Beaufighter squadrons when possible. New pilots were given additional training and close supervision. But the war required rapid expansion of aircrew numbers, and not all pilots had the luxury of extended training. The result was a higher attrition rate among less experienced crews. At higher levels, the Air Ministry and Bristol Aircraft continued discussions about potential solutions. Engineering studies were conducted. Prototypes with modified configurations were tested. But the conclusion was consistent. No fix could be implemented without halting production and redesigning the aircraft. The strategic calculus favored continued production. The Beaufighter, despite its flaw, was contributing to the war effort. Losses due to ground handling were deemed acceptable compared to the losses that would result from not having the aircraft in service. The Beaufighter remained in operational service until the end of the war. Later variants incorporated incremental improvements, but the fundamental handling characteristic persisted. In some theaters, particularly in the Mediterranean and the Pacific, the aircraft performed well in strike and anti-shipping roles. The heavy armament and long range were valuable, but the ground handling issue never went away. Every squadron that flew the Beaufighter dealt with it. Every pilot who flew it had to manage it. The accident rate associated with the swing remained elevated throughout the war. After the war, the Beaufighter was rapidly retired. It was replaced by jet aircraft and more modern designs. The handling issues that had been tolerated during the war were no longer acceptable. The aircraft's operational record was mixed. It had been effective in combat. It had contributed significantly to night fighting, anti-shipping strikes, and ground attack. But it had also killed pilots and damaged aircraft in accidents that were entirely preventable with better design. The legacy of the Beaufighter was not one of unqualified success. It was one of compromise. An aircraft that was fielded despite a known flaw because the need was urgent and the alternatives were unavailable. The Beaufighter's story is not one of catastrophic failure. It is one of persistent, unresolved compromise. The aircraft met an urgent operational need. It performed its missions effectively, but it carried a design flaw from the first flight to the last. That flaw was understood. It was documented. It was studied. But it was never fixed, because fixing it would have required stopping production and redesigning the aircraft at a time when neither was possible. The decision to proceed with an imperfect design was rational within the constraints of the war. But it was a decision with consequences. Pilots paid the cost. The Beaufighter never recovered from its flaw because recovery was never prioritized. The aircraft was needed as it was, and so it remained flawed and operational until it was no longer needed at all.